Let me start recording. So this is, oh my God, we're in week 9 now. Can you believe that? Can you believe that? We're in week 9? Can you believe that? Yeah, it's funny. I don't know why you're laughing. But anyways, so this is now lecture number 17.
I'll let you teach class.
Okay, thank you. All right.
What were you gonna have for dinner?
We just had dinner. We just had dinner. Yeah. Okay. Wow. But I like the way you're thinking. Like, what are we gonna have for dinner right after having dinner? That's how you get this. Okay.
Dessert.
So dessert. Oh, dessert is good. Yeah, I want dessert too. All right. Anyways, the quiz. Let me load it up. Okay, so I'm gonna download this and then I'm gonna share my screen. So let's do the quiz. Okay, we're gonna go over the quiz now. Okay?
Okay.
Okay. So let me share my screen. Yeah, okay. While playing craps, you make an 11 bet where you win $16 if the sum of the two dice is an 11. You win nothing with any other sum. Part A, make a probability distribution table that gives all possible outcomes of one roll of the dice. You're not rolling one die, you're rolling the dice and the probability of each. So if you roll a dice, a pair of dice, one roll, you can get a 2. And how likely is getting a 2 if you roll one die? What's the probability of getting a 2?
1 out of 36.
1 out of 36. What is the next possible outcome you can get when you roll 2 dice?
3.
3. And what's the probability of getting a 3?
2 out of 36.
2 out of 36. And so on up until, of course, yeah, it's funny. Up until the last one, of course, I'm going to do ... because I'm lazy, but to get it correct, you have to list them all. What's the last possible value?
12.
12. And what's its probability?
1 out of
1 out of 36.
1 out of 36, right? So that's part A. That's not new. You should have had that in your notes because we've done this problem before. Now part B, use a formula to compute the expected value of one roll of the dice. Well, the expected value, you take each possible outcome and you multiply it by its corresponding probability. So 2 times 1 over 36 plus 3 times 2 out of 36.
Yeah.
And you add them all together up until the last one, which is 12 times 1 over 36. And if you do it correctly and you don't round, the answer is 7. Okay. Part C, it costs $1 to play this game. What is the expected win or loss, say which, for a player on each roll of the dice? Well, there's 2 possibilities. Possibility 1, you lose $1. Possibility 2, you win $15.
Right, you're still losing $1.
Not 16 because you paid $1 to play, but $15. What's the probability of getting a negative one, of losing $1? Well, since the only way to win is by getting an 11, which is 2 out of 36, the likelihood of winning nothing is 34 out of 36. If you're hungry, go downstairs to your dad. And the likelihood of winning $15 is getting a, oh, don't hit my elbow.
2.
A 2 out of 36. And therefore, if you do the math, it comes out to be about negative point, I think it was 1.1, if I remember correctly, which means your expected value is to lose 11 cents per roll. Of course, hey, pick up your rocks. Of course, it makes sense that you lose money because if you won money, the casino wouldn't want to play this game. Their whole objective is to win money and to have you lose money. So 2 possibilities, you lose $1 because that's what it costs to play, or you get $15 minus the one that you played plus $15. This is negative 4 over 36, negative 2 over 18, negative 1 over 9, or negative 0.11. So let's clear everything and go to the second page, or the second question. It says, the prizes in a school raffle are 30 movie tickets for $14 each, 10 Hatchimals, whatever those are, for $60 each, and a new bicycle worth $500. And the school's going to sell 200 tickets. What's the fair price for a ticket? Well, the fair price for a ticket would be, we did a problem like this. You take the total cost of all the payouts, which is 30 tickets for 14 each, 10 tickets for 60 each, and 1 bicycle for 500. And you divide that by the total number of tickets sold. And if you do it correctly, it should be $7.60.
That was it. I
That was
never
it.
got that one.
That was it. The total is how much the school has to pay for all of the items, and divide it by how many tickets, so that each $7.60 ticket helps recoup the loss of the amount that they have to pay. Of course, if I were the school, I would charge $10 a ticket, so they can make $2.40 profit for each ticket, which is, 200 tickets at $2.40 each is, $500, give or take. Right? You want to make a profit. Otherwise, what's the point? Okay. So that was the quiz. Things are always tougher when you're in the spot, but once you saw the answers, was it a hard quiz?
For me, yeah.
Well, not in hindsight. I'm not saying was it hard when you did it. I'm saying now that you saw the answers and you know how to do it. In hindsight, should it have been, I guess maybe should it is a better word. Should it have been challenging now that you see what the answers are?
I guess I just set up the problems wrong.
That's fine. I was kind of liberal on points. I was trying to be very generous on points.
Fair, I don't really expect much of myself in math anyway, so.
Okay, well,
it was challenging both times.
You know what? I'm not looking to fail anyone here. I'm looking to, obviously if someone never comes to class and doesn't do any homework and doesn't take the quizzes or the tests, of course they're going to fail. But if someone is legitimately trying the entire semester, I have no plans of failing anyone. I can't promise A's to everyone, but I, recognize efforts and.
Yeah, I'm just looking for a C.
You're just looking for a C?
For me, that's an accomplishment because my math skills are terrible.
Well,
we're history.
I find it, I'm not saying this is a good or bad thing, but my sister, for example, she's very outspoken for how bad she is at math. And she says it with a smile, like, oh, I'm horrible at math. Like, and I'm just thinking to myself, if somebody were illiterate, would they ever say, oh yeah, I can't read, ha ha ha? Would that ever, huh?
Probably not.
Probably not. But for some reason with math, it's like okay to act like it means nothing. And what I'm telling you, Talar, is it's okay to be bad at something, but you should always strive to be better. And I personally think when you laugh it off, it's kind of like you're giving yourself mentally the okay not to try. I don't know if that's true or not. That's just the impression I get with my sister. And I don't know you as well as my sister. I think I'd like you more than my sister. But the point is that I think when people laugh it off, it kind of gives them a mental excuse to not give it their all. And all I'm asking is, I'll do whatever I can to help everyone pass on my end. I just want you on your end to try to do your best at the same time. I hope that makes sense. Okay. Always aim high. Yes, Solaire.
I just have a clarification question for the third question on our quiz.
Thank you so much. What are these?
Cookies.
I know they're okay. I know they're cookies. I can see they're those with the type of cookies.
To my dad and you. I
Great.
got my two.
Chris, Chris? Yeah. Are those peanut butter?
Oh my gosh.
Yeah, okay. So the whole allergy thing, can you come up here and get rid of them, please?
Oh no. Did you just touch something you're allergic to?
Yeah.
Don't rub your face.
Are you good?
I use
shit,
my other hand.
no.
Okay.
Can you get rid of those?
Oh my
Go wash
god.
your hands. Go wash your hands.
It's okay.
We have disinfectant wipes now.
If you
guys,
have a reaction
I will be
to
right back, okay?
Yes,
your hands.
please. Go wash your hands. Oh my god.
Ethan.
Go wash your hands.
Oh my
Oh my
god.
gosh.
That's
No.
scary.
Oh my God.
Oh, my
Imagine if you would have.
goodness.
No, no, no.
Did one of us put 911 on speed dial just in case?
Huh?
Oh
That
my
was
goodness.
really
Ready, doll?
funny.
Okay.
Are you okay?
You're alive.
Yay!
Thank you, though. A thought means a lot to me.
Is it an allergy or a sensitivity?
That's an allergy.
Okay.
Like, how bad of an allergy?
It's not fatal type thing, but like I get hives and my face swells up to like half the normal size and an
Goodness.
unbearable scratching and
Oh
burning.
my goodness.
Thanks. So, okay. That's okay. I don't have like an epinephrine pin or anything like that. It's not enough. It's not enough for that. Gabe, I'm gonna have to ask you if that's okay not to eat them near me because the smell makes me sick. Is that okay? You have no idea what I'm talking about, do you? Okay, here he is. All right. So that didn't work at all as I was expecting. So Larry, what's your question?
So my question is because of the for the quiz for the third question. I
Yeah,
was looking at our notes for reference for chapter 7,
yeah.
and the question about the roulette and the expected win or loss. So for that one, we hadn't put a negative value for your loss because you're paying to bet.
So I think so. We did one of two possible things. There's two possible ways of solving the problem. One way is to look at it with total net change per roll. So if I roll, there's two possibilities. I can either lose $1 or lose 1 but get 16 for a net gain of 15.
Okay.
The other possibility is to look at it solely in terms of winning. I can either get 0 or I can get 16.
I get it.
But whatever that I get as my answer, minus $1 for playing.
Oh.
Okay, so if I do either of those, I would have gotten the right answer. Are you saying that we never did anything similar?
We did something similar.
I agree with her because I was trying to reference between, I think, the set of notes on chapter 7 on pages 1 and 2, and then I went on page 9, and I was extremely confused because it was really vague, so I couldn't really determine which formula to apply that to. And I even wrote that when I submitted it. I don't usually leave it blank, but it was really vague.
I saw your email. So Larry, can you hold up your notes?
My notes? Yeah.
Yeah.
Is his name Gabriel?
Yeah.
Hey, Gabriel. Your friend will get really sick if you blow food into his face.
Could you mind taking him?
Good eating peanut butter cookies.
Yeah.
I never knew
You never
had a
knew?
peanut allergy.
That's okay. It's
Neither
okay.
did your dad.
He doesn't know much about me. He doesn't even know my birthday, so that's okay.
This one.
Hold on.
You've got your mouth covered.
I'm gonna highlight this.
I'll drink some water so you don't smell it, okay?
Okay, thank you.
That was really cute.
Hold on a second. And
So this is the way we had done this problem in class. We
Okay.
never took into account the negative for
okay,
losing $1.
yeah, I'm just looking at it. Give me a second.
Hey, let's go. Here, grab her water.
Please. I want to see.
I don't think we ever mentioned talking about subtracting $1 at the end.
Thank you. That's fair. Okay.
Yeah, I realized those examples she showed, I used that example for 1 because
Okay.
I thought part A included the numbers in the question. So I was thinking that, okay,
That's fair. Okay, so what I'll do is I'll go back and I'll yeah, I'm okay. I'll go back. I'll just throw in 10 points for everyone's answer.
Oh my
Everyone-
gosh.
I'll just knock everyone up 10 points. Gabriel,
Thank
you
you.
have to go now. Your dad's waiting.
It's
for
not
you.
even about the points. I just wanted to make sure I understood what I was doing. But
Yeah,
thank you.
no, because if you read that question carefully, it asks about the payouts,
Yeah.
right? And this question didn't ask about the payouts. This question was a little different, asking about the fair price to pay. So it was it was more about, this one was more about how much you're going to win or lose on a roll versus what's the appropriate price to pay for, yes. Okay, bro. Okay. You have to go downstairs now. Okay, please. Please. That's my medicine.
Gabe, come back in an hour with a really pretty picture drawn.
Yeah, do
Yeah.
that. Go draw a picture. Can you draw a picture?
We don't have any paper.
Okay. Please don't take my medicine. Okay. All right, but I have to teach now. Okay. Okay.
Oh no.
Yeah. Okay. All right, guys. Anywho, so I'll do that. And Dad, can you take him downstairs?
Yeah, come,
Gabriel, please.
come, Gabriel. Gabriel, come on.
This is why I don't have one.
I can't come because you're doing the Zooming.
This is why I don't have one. Okay.
Don't get upset.
Okay. All right. So now let's start on, I believe, chapter 13, correct?
Yes.
Okay. So let's all please load up chapter 13. And I will share my screen. And here we go.
This is the most entertaining class I've had.
Yeah, not the way I was hoping. This isn't what I wanted. I thought I downloaded it. Hold on. Oops, that's something else. So download. Oh, here it is. Okay. Okay. So we can all see it? Okay. 13 on variability. Okay. Statistics has often been called the study of variability in data. Okay, if all data was exactly the same, you wouldn't need stats. The whole point of statistics is that data is not always the same, and yet we want to understand overall trends and patterns from the data that we get. So let's take a look at these. We have 2 basketball teams here. We have team 1 on the left playing versus team 2 on the right. And as you can see, the heights of each player is, of course, different. They all have different heights. Whether you look at it in feet or whether you look at it in inches, either way, they're going to be different heights. And we want to compare the mean, which is the average height, as well as the variability, which is a measure of how spread out the data is. The average and how spread out the data is. Okay, now, when it comes to how spread out the data is, there are multiple ways that we can measure that. Okay, there are multiple ways that you can measure what it means for data to be spread out. And we're going to learn a bunch of them. And unfortunately, the one that is the most important is also the most mathematically complicated. And as such, if we do it by hand, it's really, really annoying, which is why we try not to do it by hand. We try to find a computer program to do it for us, okay? Because it's annoying. So let's scroll down. Can you please record? I'm recording, right? I think.
Yeah.
Okay. Oh, and by the way, just so you know, one of my other classes, they one of the students volunteered to set up a YouTube page.
Oh, nice.
And started uploading the videos onto the YouTube page.
Thank
So what
God.
I'm going to try to do is do that for all my classes, so I can not have to worry about Zoom, putting them on Zoom because it's so difficult, and I'll just go right to YouTube and put them all there.
That's actually a lot better.
So yeah, so hopefully I'll get that done ASAP. Okay, so the California Common Core State Standards has this goal for 6th grade students. Students recognize that a measure of variability, either the interquartile range or the mean absolute deviation, can also be useful for summarizing data because two very different sets of data can have the same mean and the same median, yet be distinguished by their variability. In other words, if I just tell you the mean and the median, that's not enough. There's still more information. And that extra information we want to make sure we get from the formulas that we're going to learn. And this is the standard for Algebra 1. Use statistics appropriate to the shape of the distribution to compare center and spread of two or more different data sets. In other words, it's not always the mean that's the appropriate measure of center. It's not always the median. And when it comes to spread, it's not always the IQR, and it's not always the standard deviation. There are times that you would use each one, and we will need to learn what those times are. So in this lesson, you're going to learn about 3 measures of variability: the interquartile range, also called the IQR, the mean absolute deviation, which is very rarely used, and the standard deviation, which is used more than anything else. So first, why not the... Sorry?
I was going to say, can you keep it on those real quick so I could write them?
So you want me to keep it on this thing even though I'm recording the video? Got it. Okay.
Oh, sorry.
No, I'm just joking. Go ahead. It's okay. I'll just check Facebook or something while I'm waiting. I'm just joshing. I mean, I am checking Facebook, but you know, just tell me when you're ready.
Okay, you can move on.
Okay, so why not the range, first of all? When you look at these 3 things here, the range is not one of them. So first, what is the range? The range is max minus the min. The range is a number. That number is the biggest minus the smallest. That's a definition. The range of a data set is the largest minus the smallest. So why not the range? Isn't that the greatest measure of variability? Oh, it's this wide. Lowest to highest. Doesn't that seem like it's the greatest measure of variability? Taking off?
Yeah.
Good seeing you again, even though you tried to kill
Likewise.
me. Even though you tried to kill me. When do you come back next?
I don't know.
All
I don't
right.
know. Just kind of up in the air.
All right. Okay.
But
Well, it was good.
definitely when we can hang out more.
All right.
But I
Yeah,
know,
yeah.
I know you're busy. I'm busy too.
Good seeing you though.
All right, dude.
Until next time, man. Okay. All right.
Students.
Bye, students. Right. Okay. So why not the range? So the answer is that, first of all, it's not very descriptive. Okay. Look at these 2 distributions here. Okay. What's the range of the one on the left? What's max minus min for the one on the left?
23 minus 13.
10.
Right. 23 minus 13, which is 10. And what's the range for the one on the right?
The same.
It's also the same. They both have the same range.
Oh, it doesn't show good.
Yeah, they have very different distributions, correct?
Mm-hmm.
Okay. And it says some students think that the distribution on the left has a larger variability. It varies more. I guess it varies more because there's more options. Maybe that's what they think. There's more options, so it varies more. But actually the one on the right has the greater variability because the 2 values that you can get, 23 and 13, are extremely spaced apart versus on the left where the values that you can get are actually relatively close to each other. So variability is kind of hard to really quantify when you don't have formulas, okay? And the range doesn't do a good job. The other reason is that the range is extremely sensitive to outliers. You can have one major outlier and the range will go up significantly, correct? Right? If you add one outlier, bam, my max is now bigger than it was before.
Right.
So the range is very sensitive to outliers. And as a general rule, we want something that is not sensitive to outliers.
So when do we use the range?
We never use the range. I mean, look at number 3. No one actually uses the range. It says it right there. No one actually uses the range. It is never used. You can give the min and max. You can say, oh yeah, it goes from 13 to 23, but no one says, oh yeah, the range is 10. Okay, the range is not a useful measure of variability. Okay, they almost never say the range is 10.
Can I ask why it's a thing then?
Well, it's a definition because mathematicians like to define things. Okay, we like to give names to things.
All right.
And sometimes
When
things
would we use it?
we would, but sometimes things were used historically, and it was only later determined that other things are significantly better.
Mm-hmm.
I'm not saying this is necessarily the case, but it's possible that historically the range was used at some time and therefore was given a name, but we certainly don't use it now. That I can say. Fair enough?
Sure.
Okay.
Yeah.
Okay. So now we have the IQR, the interquartile range. Okay. The interquartile range is much better. It's a measure of variability, but it doesn't go to the max and the min. It uses Q3 and Q1, which we defined either last class or the one prior to that. I don't recall exactly when. Q3 is the right edge of the box. Q1 is the left edge of the box, right? We have min, Q1, median, Q3, non-outlier max, and then max. So Q3 is here and Q1 is here. So the IQR, the interquartile range, is a distance from the first quartile to the third quartile. And if you have a major outlier, that does not really affect the IQR. Q1 and Q3 barely move, if at all. And as such, it's a much better measure of variability. You're basically saying the middle 50% is from here to here, rather than everything. So let's do an example. The heights of children of the same age are quite variable. The growth charts on page 4 and 5 contain an amazing amount of information about that variability. So I don't see any growth charts on page 4 and 5. I don't know what they're talking about.
It's right here.
Are you sure it's not page 7? I'm seeing a growth chart on page 7.
There you go.
Oh, there we go. Growth chart on page 7. Okay, it's at 4 and 5, and
Maybe in paper it is, but on PowerPoint.
that
No,
could be.
you're definitely wrong. I printed it out. So
That could be. But okay, but it is a few pages down. We have the growth charts. They are sideways. So this one says this is a CDC growth charts. Stature for age percentiles for girls aged 2 to 20 years. So girls at 2. Okay, we have, oh, I see. So we have, if you look here at the labels, the 5th, 10th, 25th, 50th, 75th, 90th, and 95th percentile.
Professor,
So Lara, question?
there's a button where you can rotate the page.
Yeah. Okay.
Right there. The square with the arrow on it, it only does that page.
Crazy what they can do nowadays. I'm like sitting like this the entire time. Thanks for waiting until my neck broke before letting me know. So there,
That was the plan.
You're wonderful. So if I said, for example, well, I'm sure they have some good examples here. So this one here must be boys. Okay, so let's see what the questions are. It says, so let's go through the questions. What is the approximate percentile for a 9-year-old girl who is 49 inches tall? 9-year-old girl, 49 inches tall. So we go to the girl charts and we go to age 9 and we go to 49 inches tall, which is right there, right?
yeah.
What percentile would that girl be in?
Is that or
Yeah, that would be, well, not quite the 10th, maybe the 9th or 8th percentile.
Wait, I'm confused. How can you tell?
Because she's between these two curves, correct?
Okay.
And if you follow these curves to the end, that curve is a 10th percentile curve, and this curve is the 5th percentile curve.
yeah.
So if I go to 9 and 49, which is right there, we see that she is between the 5th and 10th percentile. So that is a rather short girl in the grand scheme of things,
Okay.
right? At her age, she's only taller than 10% of the other 9-year-old girls. Okay, so she's on the shorter side. Okay. About how tall does a 12-year-old have to be, a 12-year-old girl have to be?
Buster?
Sorry?
Sorry, what exactly would be the answer for the first question?
I would say the 9th percentile.
Yeah.
Okay, if you go here to 9-year-old girl, 49 inches tall, which is this corner right there. That actually, I apologize, it's probably more like the 6th percentile. 9-year-old girl, 49 inches tall is that corner right there, right? That is much closer to the 5th percentile than it is to the 10th percentile.
What of the key? Mexico.
You know I'm recording this, right?
Yes. Door.
Okay, so the next question is, about how tall does a 12-year-old girl have to be so that she's as tall or taller than 75% of the girls her age? You can grab them. I wouldn't mind at all. Okay, so 12-year-old girl, 75th. Bye-bye.
Bye-bye.
So 12-year-old girl, that's right here. And we are curious how tall she has to be taller than 75% of the girls her age. That means that she would fall in the 75th percentile. So we go up until we hit the 75th percentile curve, which is right here. How tall would she have to be?
61.5 inches.
About 61.5 inches. Okay, about
Can we just say
5.
62?
There's a button on the wall when you first walk into the garage. But the upper button.
Can we just say 62?
No, it's not 62. It's still like 61.5. 61.5, because 62 is certainly over the 75th percentile. Right? It's right there, which looks closer to 61.5 than 62. Try to be as accurate as you can.
But doesn't she want to be taller than the 75th?
It's not a matter of
as tall.
No. When she is as taller than 75%, by definition, that means she is at the 75th percentile. That is exactly what it means to be taller or as tall than 75% of the population. If you say, oh, it's above that, then that's already 76 or 77 or higher. 75th percentile literally means as tall as or taller than 75% of the population. Now, how tall does the 12-year-old boy have to be for the same percentile? So for a boy, we go to the boy charts. He's 12. We're going up. We want to reach the 75th percentile for him, which is right there.
That looks like about 61.
That's
60 point something.
60.6, 60.8, something like that.
Sure.
Interesting that a boy is shorter than a girl.
Well, that's what happens most times. That's
Is
like
it?
a thing where girls are
first, and
taller
then
for
boys
a
get it
certain
later,
while.
but there it goes faster.
Okay, so I heard like 4 people talking at the same time, but I think I got the gist of it. You're saying girls start off taller and then boys catch up and beat. Okay, not beat. Not like it's a race, but I'm saying they get taller.
Yeah.
Okay. I did not know that.
Well, now you do.
Well, not you guys are teaching me as much as I'm teaching you. So, all right. How can you tell from the chart when children are growing the fastest? How can you tell from the chart when children are growing the fastest?
The curve gets pretty steep.
Like
Excellent, excellent. It's all about the steepness of the curve. Fantastic. Right, excellent. I heard that right off the bat. It's when it's steepest. So it looks like girls are growing the fastest really in the beginning, I would say. Oh, this is boys, right?
Yeah,
That's boys. I would say it's the beginning.
So girls probably also in the beginning. Yeah, look, very steep here. very steep. And then it shallows off. And then right around, it looks like right around 14, 15, it just majorly, no matter what percentile they're in, it just kind of collapses off. With boys, the collapse occurs later. Right? So it looks like, yeah, so it looks like girls grow faster. And then around 15 or so, they pretty much stop. And boys are still growing and they stop at 19 or 20. I don't know why that's the case. I mean, this is empirical data. This is not theoretical, right? They're using data that they collected. I don't know why that's the case. I'm not trained in any way, shape, or form to understand the why, just the what. So we did that one. Is there more variability in the heights of 2-year-old girls or 14-year-old girls? Compare 2-year-old girls and 14-year-old girls and ask yourself which one has more variability.
That's the boys chart.
God damn it. All right. 2-year-old girls or 14-year-old girls?
14-year-old.
14.
Yeah, I mean, 2-year-old girls seem to range. I mean, this only goes from 5th to 95th, so it's not like the top 5 or the bottom 5%. But that middle 90 seems to go from about 31 inches to 36 inches, which is a 5-inch variability. Whereas for 14, it goes from 59 to 67 plus, which is 8 something, right? So it's more, not that much more, but it is more.
So more variability on the 14-year-old.
More variability in the 14-year-olds. Okay. So let's do this one. What is the 25th percentile, the 50th percentile, and the 75th percentile for 4-year-old boys? So let's go to the chart here. We go to boys, make sure it's the boy chart, which it is. We go to the 4th percentile, which is here. And first we want the 25th. Now looking here, the 25th is the 3rd curve. 50th is the 4th curve. 75th is the 5th curve. So 3rd, 4th, and 5th curves. So was it 4-year-old boys? I forgot. 4-year-old, right?
Yeah.
So the 3rd curve seems to be 39 inches. That's a 25th percentile.
Wait, how did you do that again? Sorry.
Which part?
Where you went from percentile to age, like the last bit.
Oh, well, the 25th percentile is the 3rd curve.
Okay.
So I went from 4,
you
I
just
hit
followed
curve 1,
the curve
curve
down.
2, curve 3. Okay. Right? So 39 inches is the 25th percentile. 40 inches is the 50th percentile, and then 41.4 inches or something like that is the 75th percentile. So what's the IQR?
Q3 minus Q1.
Q3 minus Q1. Q3 is the 75th percentile. Q1 is the 25th percentile. So the 75th is 41, let's say 0.5. And this is 39 point, let's say 2. So you subtract them and you get whatever you get. I don't remember what the numbers are.
2.2.
Okay, I believe you. 2.2. I didn't do the math. 2.2. Okay, so write a sentence in context interpreting the IQR for 4-year-old boys.
Sorry, Professor, can you go over that one more time?
Which part?
So it was the IQR. So we're taking the 41.5 and subtracting it from 39.
Yeah, so the IQR is the 75th percentile minus the 25th percentile.
Okay.
By definition, that's what the IQR is, the 75th percentile minus the 25th percentile.
And then how did you get 2.2?
Well, I just subtracted them.
He said 39.2 and 41.5.
Oh, 39.2. Okay. See, I got 9 for them.
So lots of information there. Okay. So let's look now at this one here. The IQR and the box plot. Example. Oh, we did this example before. Okay. At least we talked about this example before. So the question is, which method would you choose as the most effective? That's the one that probably has the highest median. So I would choose group 1 with the highest median versus the other ones. But that's not really what we want to focus on right now because the chapter is on variability. So which group has the most variability as measured by the IQR? Which one has the most variability as measured by the IQR?
Looks like 2.
2, right? It's the biggest box.
Yeah.
You don't got to do any calculations, right? It's the biggest box. Now, what is the IQR? Well, that does require calculations. So what is the IQR, at least approximately?
Q3 looks to be roughly 39 because it's not exactly on the 40.
Wonderful.
And then I can't tell if the beginning of Q2 is on the exact line, but
Probably 5.
I would say so, maybe.
Okay,
Yeah,
so approximately. So what do we get approximately? About 34?
Yeah.
Yeah.
Okay. I mean, listen, without accurate, you know, a ruler or something, I would take anything from probably 30 to 40, give or take. Not 40, but somewhere in the vicinity of 35. Okay, so the IQR is equal to the length of the box. Obviously, that's where we get it from. Okay, so that's the IQR. That's the first measure of variability. Well, 2, the range, but we don't use the range, right? So the range, we don't use, the IQR we do use. The next measure.
Professor, I have a question.
Yeah.
Can you please go back to slide 6, because I don't feel like I got a good, at the end it says write a sentence in context interpreting the IQR for 4-year-old boys. I would like to hear a sentence that you think is acceptable for that.
So here's what I would say.
Mhm.
I forgot the numbers. So I'm just going to say 38 and 42 because I don't know what the numbers are. I'm just going to make up numbers. The middle 50% of 4-year-old boys have heights that range from 38 inches to 42 inches. Again, those two numbers might not have been the numbers that we used. I don't remember what they were, but that's what I would say. And it encapsulates the idea.
Okay, thank
Does
you.
that make sense?
Yep.
Okay. So now we have the MAD, the mean absolute deviation. I recall growing up, my mother was a member of MADD. Anyone know what MADD is?
Mothers Against Drunk Driving.
Mothers Against Drunk Driving. And I thought later in life that she should have been a member of DAM, Mothers Against Dyslexia. No, nothing? Not see how you switched the letter.
I got it because you said DAM and then started with mothers, and I was like, wait a minute.
Anyways, so MAD is mean absolute deviation. So one way to think about variability in data is to examine how far the data values are from the mean. The range and IQR do not do this. The range and IQR just line them up and say from here to here, from here to here. But the mean absolute deviation is about how far data is from the mean. So let's do an activity. 4 Brownie Girl Scout troops each have 9 girls.
Woo, Girl Scouts. Sorry.
Yes, it's okay. I just heard Brownie and I stopped really thinking too much about anything else.
Well,
but,
no, because I was a Girl Scout, so I get excited.
I understand. Okay, so 4 Brownie Girl Scout troops each have 9 girls. The number of boxes each girl sold on Saturday are given below. Troop A, B, C, and D. So use the idea of the mean as a balance point to verify that the mean number of boxes sold by the girls in each troop is 6. What do they mean by using the mean as a balance point?
I'm trying.
It's the middle.
You took the mean out of all of that. Like if you did the mean separately for all troops, and then compare them somehow.
Well, we're not comparing them. We're not comparing them. We're just looking at each one individually and saying, oh, the mean is 6. Now, just so you should know, if I was asked to compute the mean of any of these, I would just add them up and divide by 9.
Yeah.
Right, but aren't we doing what we learned last time, which is basically having 6 be the balance point? And so we're gonna.
Well, we're trying to
a number line.
We're trying to establish that 6 is the balance point. We don't know that 6 is the balance point, right? It says use the idea of the balance point to establish that each of the means is 6. So look at the first one. We have 6, right?
Mhm.
5 and 7 are each 1 away from 6.
Mhm.
4 and 8 are each 2 away from 6. 3
Oh.
and 9 are each 3 away from 6. 2 and 10 are each 4 away from 6. So if these were at these locations, it would balance perfectly, correct?
Got it.
Right?
Yeah.
The next one might be a little harder. Troop C is easy because they're all 6s, lots of things at 6, and then one thing 4 to the left and one thing 4 to the right.
Mhm.
Right? So that will also balance at 6. How about Troop D? Is that an easy one or a harder one?
Wait, sorry, can you go back really quick?
For which one?
Troop B.
To B? I didn't do B. I skipped B because B was a little harder. I did A and then I did C.
D
Oh,
is
okay. I was like,
somewhat,
wait.
D
okay.
is somewhat normal. 5 and 7 are both 1 away from 6, and 2 and 10 are both 4 away from 6.
Exactly. Right. So that's also the balance point. So the only question is B. So B is a little tougher, right? We have 2 at 6, so let's ignore those.
Mhm.
If I go 4 to the left and 4 to the right, I get 2 and 10. So those cancel.
Mhm.
So now I have 2 and 2 that are 4 to the left for a total of 8 to the left. And then 2 to the right, 3 to the right, 3 to the right for a total of 8 units to the right. Again, they cancel, right? 8 units. Basically, look at the 6s. For this,
Professor, can you like draw this or something?
yeah.
Yeah, I'm really
I'll try. That's
confused.
fine. That's fine. That's fine. Hold on. Hold on.
If I'm thinking about it, Professor, the way I'm looking at it is like, would it kind of be what we talked about last Wednesday? Like we're drawing arrows to get them. You know what I mean? Like we're
Kind
never
of.
mind, I can't even say what.
Let me do it. So here at 6, we have 2 blocks. This is at 6, right? We have 2 blocks.
So 6 is our middle.
Well, we're trying to establish that. So I'm putting 6 in the middle. Okay, I'm trying to establish that. So those take care of those 2 6s.
Okay.
And then we have 5, 4, 3, 2. We have 3 blocks at 2. These are all supposed to be the same size, but 3 blocks at 2. We have 1 block at 8. We have 2 blocks at 9. And then we have 1 block at 10.
Wait, so we just choose one of these 4 and we use that to establish our thing?
Well, I haven't established it yet. I'm just putting the blocks. I'm putting the blocks down where they are. 3 at 2, 2 at 6, 1 at 8, 2 9s, and a 10.
Yeah. Okay, but like we can pick any one of the 4. It doesn't have to be a particular one.
Oh, I'm doing B right now.
Okay, sorry,
No, it's okay. This is B. This is just B.
Okay.
Okay. Now, I claim that this is the mean. Let's see why. If I look at each of these 3 2s, how far away are they from 6?
4.
And there's 3 of them, correct?
Mm-hmm.
For a total of 12 units to the left. 4, 4, and 4. 12 units to the left, correct?
Mm-hmm.
Now, this one here is 2 units to the right.
Okay.
This one here is 3 and 3 for a total of 6 units to the right. And this one here is 4 units to the right.
Mm-hmm.
For a total of how much?
12. And they cancel out.
12. They balance. The units left and the units right balance.
Wait, can you just explain how you got 12 on the left-hand side again?
There's 4. Each of them is 4, and there's 3 of them. 4, 4, 4.
Okay.
Okay. The other ones are done in a very similar way. They're easier to see, but you can do them this way. If I do, for example, this was B. If I do, for example, A, then you have 6, you have a 5, and you have a 7. The 5 and the 7 are each 1 unit away, so they cancel. I have 1 at 4 and 1 at 8. The 4 and the 8 are each 2 units away, so they cancel. I have 1 at 3 and 1 at 9. The 3 and the 9 are each 3 units away, so they cancel. And then I have one at 2 and one at 10. And those are each 4 units away, so they cancel. So every one on the left cancels with one on the right. Okay? So these are just established that the mean is 6. But you know what, to be honest, if someone asked me what the mean is for any of these 4, I would have added them up and divided by 9. That's just the easiest way for me to find the mean, is just to do it mathematically. Okay? Now that we know it's 6, the question is, which troop already is closest to having an equal distribution?
Wouldn't it be troop B?
B?
Troop A.
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 Well, equal, I don't think equal means. Oh yeah, okay. Equal means, yeah. I guess equal means every number is just as likely as any other number, right? So it's A, right? 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? It's equal across the board, one of each. Okay. So rank the groups from closest to equally distributed to farthest from equally distributed, and explain your reasoning with the help of the dot plots and or with computation. So let's look at these dot plots here. Group A had a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, and a 10.
Mm-hmm.
Group B had 3 2s, 2 6s, an 8, 2 9s, and a 10.
Mm-hmm.
Group C had a 2, lots of 6s, and a 10. And Group D had a 2, a 5, a bunch of 6s, a 7, and a 10. These are just dot plots of the data. So which one of them is equally distributed? Obviously, it's going to be the top one, the first one.
A.
Okay, A is done.
Mm-hmm.
What's the next one that you would say is equally is closest to being equally distributed?
C or D.
C or B?
C or D.
B or D? Yeah, I think C is the least equally distributed. I would say B. I would say A, then B, then D, then C. Right? A is already equally distributed.
Yeah.
B has the most spread. It's got stuff here, 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 here. Say 5 of the 9 numbers are being used. D has 4 of the 9 numbers being used. And then C has only 3 of the 9 numbers being used. So I claim, thank you, I claim that it's A, then B, then D, then C. Okay. Now, luckily, we'll have some math that's going to help us with this. So here's how the math works. The first thing you do is you find the mean. What's the mean of the first one?
6.
6. In fact, they're all 6.
They're all, yeah.
So here's what I want you to do. I want you to take every data point, subtract 6, take the absolute value, and add. So again, we have 2 minus 6, or the distance from 2 to 6 is how much?
4.
4. 3 to 6, how much?
3. 3.
4 to 6.
2.
5 to 6.
1.
6 is keep going.
0. 1, 2, 3, 4.
1 0 1 2 3 4. For a total of how much?
20.
20. Let's do B. How far is this 2 from 6?
4.
The next one after that?
4.
The next one after that?
4.
This one here?
0.
0.
This one down here?
0.
0.
This one here?
2.
2.
These 2 here?
3 and 3.
3 and 3.
This one here?
4.
4.
Add them together?
24.
24. Okay, how far is this one?
2. So 4.
4. And how far is this one?
Zeros. Oh, no, not that one.
These are all zeros, so I kind of skipped them. How far is this one?
4.
For a total of?
8.
How far is this one?
4.
How far is this one?
1.
This one?
1.
This one?
4. So 10.
10. So these numbers are the mean absolute, well, these are the numbers that are the mean absolute deviations.
I'm sorry, Professor.
I have a question. Yeah.
Ones are the very left column numbers are the mad.
Yeah.
Okay.
Yeah.
Thank you.
You're right. You're welcome.
So can you explain the thing that we wrote on the right?
Yeah, I added them all up together.
No, I get that. But is the thing on the right side of our graph, the A, B, D, C, is that totally different than what we just said?
No, he's saying that A because it's oh wait.
But then why is 24 greater? Why is 24 greater than 20?
It's not.
On our
No,
thing,
no.
Oh, no, that's the distribution.
Yeah, these were my ranking for equally distributed to least likely equally distributed. These are not these numbers.
They don't have to go. They're not connected at all.
No.
Okay, that's what my question was.
These are not connected at all. These are my rankings for which one is most equally distributed. And this was a completely different thing altogether. Okay. So I'm going to go. Sorry.
Sorry, I had a question.
Yeah.
Does finding the mean absolute deviation help with your ranking though?
Well, we'll see. We'll see exactly. Okay. Let's go ahead and we'll see. Okay. So several children use the following method to measure how far each brownie troop was from an equal distribution. And we already did this, actually. We did on the last page. Troop A, we got 20, correct?
Yes.
Yeah.
So Troop C, if you want to go ahead and fill it in, Troop C was 2, 6, 6, 6, 6, 6, 6, 6, 7 sixes, 10. Right? So Group C was 2, 7 sixes,
and 10.
And a 10. And the distance from the mean of 6 was 4.
And zeros.
Lots of zeros. And 4 for a total of 8.
Mm-hmm.
So, is the distribution of Troop A or Troop C more variable according to the method devised by these students? And the answer is A is more variable because its MAD is larger. Okay, the larger
the mean absolute deviation,
the more variable it is.
Well, say that again. The larger
The larger the MAD, the larger the mean absolute deviation, the more variable. So 20 is more variable than 8. Therefore, A is more variable than C.
Professor, so if
Yes.
we were to compare A and B, B would be
B would be more variable because B had a 24.
got it. Thank you.
Exactly.
So like how you put like A, B, D, C, like that's what you thought. Would it be whatever?
Well, we weren't, what I was doing there wasn't variability. What I was doing there was a ranking for which one I thought was the most equally distributed. That's different than the greatest variability. Okay.
So the greatest variability is just like highest number to lowest number.
Yes, exactly. By this method, by this measure of spread. Right? MAD is not the only measure of spread. We also have the IQR. Right? If I go back, I can compute the IQR for all of these, and that might give me a different ranking for which one is the most variable.
So how would we know which one to use?
They'll have to tell you, or they'll give you instructions for which one is appropriate in which scenario.
Okay, thank you.
Okay. Oh, you use the IQR whenever you see this, and it's like, okay, hey, I see this. I'm going to use the IQR.
Okay, thank you.
Okay. So the students' method worked out well because the troops were all the same size. Now suppose that Troop E had 40 girls, 20 of whom sold 5 boxes, and 20 of whom sold 7 boxes. So we have, here's Troop A with their 4, 3, 2, 1, 0, 1, 2, 3, 4.
Mm-hmm.
And now here's troop E with the 25s and the 27s.
Mm-hmm.
Which one, what's the MAD for this case right now?
100 and 140.
I don't think so.
Well, didn't you add them? Because 20 times 5 is 100.
Wait. What's
40? 20 and 20 is 40.
it's exactly, what's the mean?
Oh.
Right? By symmetry, the mean is still 6, correct?
Yes.
Right.
So they're both 1 away from each other.
They're both 1 away from each other, correct?
Yes.
And therefore, each one has a distance away of 1.
Yes.
21's here, 21's here, for a total of?
40.
For a total of 40. So the MAD in this case was 40, and the MAD in this case was 20. But which one looks like it's more variable? Which one has more differences in its values?
Should be.
I don't know. B looks, all the B's look very close to 6.
Troop
A
A.
is all spread out.
Troop
Yeah.
A.
But we got a higher MAD for B, for troop E. And the answer is that when they don't have the same size, right? If troop E has lots and lots and lots of data points, chances are it's going to add to a bigger number. Not because it's actually more spread out, just because there's so many cases, each one has a number, you add them all together, it's going to be big. Right? Look how spread out this one is. It's not spread out at all. It's all centered right next to 6. But there's so many data points, it adds up to a bigger number.
Mm-hmm.
Because of that, MAD is not really a great measure of spread. It works when they have the same data size. It works when they have the same data size. Okay, but not so well when they don't. And for that, we have to go to a more sophisticated measure of spread, okay, which is called the mean absolute deviation. I mean, this is what we're calculating, okay? So first of all, my apologies. The number that I've been giving you so far, which I've been calling the MAD, is not the MAD. That's my bad, because we have to throw in one extra factor at the end. So we have to divide by the number of data points. The top is what I've been calling the MAD up until now. That was my error on my part.
So what is it actually called?
It's nothing by itself. It's only after you divide by the total number of data points that you get the actual MAD. So going back to this case here, the MAD was not 20. It was 20 divided by 9. Okay. When you
But it's
add
a
it,
bigger percentage than 8 divided by 9, because 8 divided by 9 is.
exactly, right? So you have 9 data points. So you take the number 20. So this, over here, when I had those 4 numbers,
Mm-hmm.
it was really 20 over 9, 24 over 9, 8 over 9, and what was this case, 10?
10.
10 over 9. Okay, in all cases, we divide by the number of data points. Okay, again, my apologies. I hope that's cleared up, because that was my bad for my not including it in the original definition. I apologize. Okay, but in all those cases, the actual MAD, the mean absolute deviation, is after you divide by the number of data points, because when you do that, you take into account the different data sizes. So back to this case here, what's the MAD for A again?
20 over 9.
20 over 9.
20 over 9.
And what's the MAD for B? By the way, what is 20 over 9?
20 over 9 is 2.22222. So
This is 2.2 bar. And in this case, we got 40, but it's 40 over what?
40, so
9.
it's 1.
Oh, 40 over 20, 40 over 40.
So it's 1.
Wait, what?
So what? Oh, because 40 over 40 is 1.
40 over 40.
I am so lost.
40 over
There's
40
40
divided
points.
is
There's 40
what?
dollars.
The number
Any
we got,
number.
the number we got earlier was 40, but now we divide by the number of data points, which is 40.
Okay.
Right? We had 1, we had 1, we had another 1, another 1, another 1, another 1, right? All these things are all 1 away, correct?
Yes.
So we got a total of 40 when we added them all together. Right? Are you with me?
I think so.
Okay, so you know what? We're out of time. Let's pick up here next time.
Yeah, I'm sorry. I didn't mean to derail. I was just.
No, you didn't. We're out of time anyways. It's not your fault at all. And especially because I made a mistake. So it's always nice to restart and make sure we're on the same page. So let's start here next time with recapping what we just did with the MAD, and we'll continue. Okay, and I'll put up the quiz tool there. I'll put it up tonight, so you all have it available on chapter 11. So I will see you guys. I'll see you guys on Wednesday.
Thank you, Professor.
You're welcome. If I don't die from my allergy, but it looks like I survived. It looks
Thank
like
you.
You're welcome.
you.
I'll see you guys later. Okay.
Bye.
Okay.
Thank
Bye, guys.
you.
Have a
Bye.
nice night, Professor. Please stay
You-
safe.
I'll try.
Thank you.